ATI opens metal additive manufacturing facility for aerospace and defense. They've inaugurated a new facility that's purely dedicated to serving the aerospace and defense sectors. This is exciting. The facility aims to produce complex metal components with reduced lead times, enhanced performance characteristics, and then really leveraging the advanced 3D printing technologies, which we've made so much progress on over just the last couple of years. Scaling production here, though, while also ensuring additive manufacturing processes are meeting the industry standards, regulations, et cetera, and certifications could be difficult.
The real challenge here isn't just meeting those certifications. I think it's scaling while maintaining your process control. Additive manufacturing isn't like a traditional machining where you tweak your CNC program and keep those parts churning out. Because if they don't control every single variable in this, so you've got powder quality, you've got laser parameters, you've got thermal cycles, you've got that whole recipe that you're trying to manage, then they're going to be producing parts that technically meet spec, but fail in real world conditions. It's all about the recipe. It really is. Imagine cooking something, you put it in the wrong sequence at the wrong temperature. The ingredients might be right, but boom, it ain't working. It tastes bad.
Aren't industry certifications there to make sure that that doesn't happen, right? If the parts are passing inspection, what's the issue? Where's the breakdown?
Certifications are the finishing line, not the playbook. You can pass a test today and fail in production tomorrow. So if your processes are not locked down, so every tiny variation in additive manufacturing changes that final part property. If ATI doesn't bake in quality from the very start, they're going to be chasing inconsistencies instead of scaling their production. I mean, they're trying to hit speed, but it's no good if it catches them at the last minute where they go, well, everything else was great, but suddenly production popped it out and broke it. So
how do they stop that from happening then?
You've got to have real-time process monitoring. You've got to go layer by layer quality control with SPCs to catch defects before they get baked into that part. And then you've got to have, to make that happen, you've got to have a full digital thread integration, trace every material batch, print parameter, inspection result to avoid hidden process drift. And then lastly, for me, it's good old simulation-driven certification. So use that virtual validation to predict those failures before they happen, cutting down on expensive physical testing. Because if you get it wrong, then they're going to be printing more scrap than flight-ready parts. But if you get it right, then they're going to be scaling additive just like the pros.
Gotcha.
Next one.